Good morning. Welcome to another video on Python fundamentals. Today, we shall be talking about modular programming. And in that, we will be talking about how Python has libraries, which include modules and packages. So let's get to it. As per usual, our learning objectives is to learn how to read, to understand, to be able to go through, trace, and modify, adapt, and create Python programs that use modular programming. You're going to learn about what modular programming is, excuse me, and you're going to learn about what a module is and how you use it in Python, and what a package is, and what's the difference between a module and a package. And finally, we're just going to end it off with the pip, which is the Python package installer Python, or Python installer packages, one of the two. All right. Python package installer for Python, excuse me. Yeah. So what is modular programming? So Python modules and Python packages are two tools used to facilitate modular program. And this is essentially a way of like breaking down your large programming tasks into separate and smaller manageable modules or subtasks, right? So the advantages of this is simplicity, all right? Rather than having this 1,000 line code document, you can separate that into smaller chunks where it is more manageable, right? And you can see what's going through and you're not overwhelmed, all right? Maintainability, when you are able to break down your code into separate modules, right, or smaller subtasks, right, it gives you an easier time in managing and maintaining each module, right? Reusability, like you don't have to reinvent the wheel. You've already created a module to do a specific task. You can just import that module into your new task or program that you're trying to create. And that's why modular programming, and also scoping, okay? Now, a module is essentially a file or collection of files containing Python definitions and statements, and we import them when necessary, right? So module consists of functions, variable, constants, classes, and objects. We will get to classes and objects soon. I think in the next chapter, we'll be talking about object-oriented programming. So we will understand what we mean by what is a class and object. Remember, Python is an object-oriented programming language, right? And if you look on the right, we have a math module. And within this math module, we have mathematical functions, right? In Python, there are three ways to define a module. You can either write it in Python, you can either, and then you can write it in C, and it can be used at runtime. An example of this is a regular expression module. For those of you coming from computer science, you should understand what a regular expression is. And there's another way, the final way is to build a built-in module that is intrinsically contained in the Python interpreter. All right, so how do we use modules in Python? The following keywords that are highlighted in blue are very important. From, import, as. We will dive into them in the next slides, but these are keywords. So essentially, from is saying I want to take something from module or package, and import is saying that from this package that I want to get something out of, I want to import this specific entity into it. And the as is essentially an alias. Like sometimes you might have packages or modules that have a long name, and you might feel like, you know what, I really don't want to be typing out this name all the time. I can just shorten it and give it an alias. So that is where the as keyword is used. One popular example, if you are in the data analyst or data science or machine learning world and you're using NumPy and pandas, you will see people shorting pandas to PD and NumPy to NP, all right? Use the as keyword to do that. Now, the simple import statement, right? So this is one way how you just say import this module, right? And if you see below, I have this thing that looks like a bunch of names. And this is essentially what we call a namespace, right? So a namespace is a space in which names, like they exist, and the names do not conflict with each other, right? So this is Siabonga's namespace, this is Merva's namespace, and this is Kari's namespace. They are in this namespace, they are not two different objects with the same name. So you can't have objects in the same name in the same namespace. Now, this happens like when you're importing something. Let's say Siabonga and Merva, you see there's a Jasmine, there's a Kumocha, there's a Kumocha there. And you want to imagine these are just functions or entities, and you import them into your Python script, right? So now there will be a conflict because Python will not know which Kumucha are you referring to. Are you referring to the one in Siabonga's namespace, or are you referring to the one in Merva's namespace? So there's a way how you would do that for the namespace to not conflict. So you would use the dot notation where you would say dot module name dot the entity that you're importing, right, or using. All right. So in this example here, I would have something like Siyabonga.kumutsu. Then it would know that I am referring to the Kumutsu entity in Siyabonga's namespace or Siyabonga's module. Right. Now, how do you import a specific entity from a module? Right. So now you have this multiple. Now, if I was to say import Siyabonga, everything here would be imported. However, I don't necessarily need all four of these entities. Then we can go into importing a specific entity from a module. And to do that, we use this format. We say from module import module entity. All right. Now, another one is importing all entities in a module, right? This one is a little bit different than this, right? You can see this one, we're importing the whole module here in this scenario. But here we're saying from this module, I want to import everything, right? And in this format, right, I wouldn't have to do siyabonga.table. I could just call table, right? When I use this from module import star. However, there could be a problem, right? Remember, I said that we could have clashes with the namespace. So you have to be very careful and you have to know your program very well, intimately, when you're using this this format so that you do not have any how do you call it now, complex in the namespace. All right, so now the alias, right? Like I said, Python allows you to change the name of an entity when you import it by using this keyword, the alias keyword as, and this allows you to modify the name of the module or the module in your namespace. So now I can say import module as alias. Like I said, you could, when you are, for those of you who have dealt with data analysis and data science projects or even machine learning projects, you would have seen this where you say import pandas as PD. For those of you who don't know, pandas is a very popular tool, useful tool for data analysis. All right. So from module, import a module entity, and you can rename that module entity as an alias. All right. So a package, essentially. Now, what happened if you have modules of the same name, right? A package essentially avoids collision between modules. And another package essentially is just a collection of related modules, right? And you can use the dot notation to access a module within a package as well, right? So I'm just showing you like the sets. Like a module is a subset of a package and a function is a subset of a module, right? So within modules, you have functions. You can also have other entities, right? So it's not only functions that are in modules. You know, you can have like constants, you can have variables and all of that inside a module. But essentially, I'm just trying to highlight that, okay, within a module, has several functions, right? And then within a package, you have several related modules, okay? And then finally, the package installer for Python, right? This is a tool that allows users to access a wide collection of a wide collection, not a wild collection, but a wide collection of Python packages. And you can install these packages from pip and other indexes. I will show you how to do this in the way we're using Visual Studio Code. But this is a very useful tool for when you are programming and you need to import the libraries that you need to use, because Python. One of the reasons why Python is quite popular, because it has an extensive collection of packages that are how do I say, that are wide use, and also there's constant updates, and there's large team of software developers that are contributing to these packages. All right, and then our key takeaways. All right, so a module is designed to combine related entities, right, such as functions, variable, constants, etc. And a package essentially is just a container for several related modules, right? Okay, and you can access them under a common name. And Python, okay, so this is where we now start dealing with the importing, right? I'm going to show you this in the Visual Studio Code, but Python translates the source code of a module at first import to a semi-compiled format in PYC files. You see this in the VS Code video, and Python uses a naming convention to encapsulate or to treat encapsulation of variables, right? And this init py is run implicitly when a related package is imported. And when you're creating your own packages, you should have that init py must be present so that it can be considered as a package. All right, so let's jump into the Visual Studio Code. I'll see you there just now. Cheers.